Alright, day 12, homework. Parallelogram PQRS has one angle that is 46.2 degrees more than another. Find all the angles. You should draw a sketch of the parallelogram, which I'm going to do right now. Okay, so there's a sketch. Okay, so let's say this is P, Q, R, S. Okay, so one angle is more than the other. I'm going to call the smaller angle X, and I'm purposefully putting it as an acute angle. I'm going to call the larger angle X plus 46.2. So this one up here will be X plus 46.2 because it's 46.2 degrees more than the other one. Now, notice that these two angles they're consecutive. Okay, these angles will be supplementary. So when I make my equation, it's going to be the supplementary equation. The x plus 46.2, if I add those together, it should equal 180. So that's what I'm going to do. Now these parentheses aren't really doing anything because there's no distributive property or anything. So I'm really just going to combine my like terms right here. If I put those together, that's going to make 2x. So now I've got 2x plus 46.2 is equal to 180. All right, time to subtract 46.2 from both sides. 180 minus 46.2, that's 133.8. Okay, so I've got 2x is equal to 133.8. Time to divide both sides by 2. Okay. So divided by 2, that gives me 66.9. All right, so x equals 66.9. All right, now in terms of this, this parallelogram, we now know that this angle is 66.9. All right, which means this angle is also 66.9. Remember, the other angle is supposed to be the first angle plus 46.2. It's 46.2 more. So the other angle is going to be 66.9 plus 46.2. So that's 113.1. Okay, so this angle, like angle Q, is 113.1. So is angle S. Okay, so basically you could say the acute angle, I'll put it this way. The acute angles are both 66.9, and the obtuse angles are both 113.1 degrees. Okay, so that is how you do number 1. All right, number 2 is going to be very similar. Okay, it's my trapezoid again. Now, one angle is 6.2 times the measure of the other one. The last one said it's 46.2 more than. This one says times. Let's see how that looks different. Again, I'm going to just call my acute angle x. So the bigger angle will be the obtuse angle. So if it says 6.2 times another angle, that means literally 6.2 times the other angle. So notice on the last one I did x plus 46.2 because that was 46.2 more than. This time I'm doing 6.2 times x because it says 6.2 times the measure. The rest is going to be the same. Again, these are supplementary. So the equation is going to have to be like this. X plus 6.2x is equal to 180. They are supplementary. If I put these together, remember, this is like having 1x. So this will make 7.2x is equal to 180. And so then I'm just going to divide. So if I divide both sides by 7.2, that should give me my answer. Okay, so 180 divided by 7.2. $25. Okay, so x equals 25. That means that this angle is 25 and this angle is 25. Alright, the other angles should be 6.2 times this. So if I do 25 times 6.2, I get 155. So that means this angle is 155 and this angle is 155. So basically, the acute angles are 25 degrees. The obtuse angles are 155 degrees. Okay, so that's the answer to number 2. Number 3. This is a parallelogram. Find x. The big mistake that kids often make is to set these equal to each other. But look at these angles. One of them is a small angle. It's acute. One of them is an obtuse angle. There's no way these are going to be equal. If they were across from each other, they would be equal. But these, instead of being across from each other, these angles they share a side. These are consecutive angles. So again, just like on the last 2 problems, these are supplementary. So I need to show them adding up to 180. So this is going to be like this. 5x minus 7 plus x plus 1. Okay, this angle plus this angle has to add up to 180. Okay? So, in this case, the parentheses are not really doing anything. So I'm just going to combine like terms. So 5x plus x, that's 6x. Okay, negative 7 and positive 1 make negative 6. Alright, and that's equal to 180. So I'm just going to add 6 to both sides. So that's going to give me 6x equals 186. Time to divide by 6. Okay, so that should give me the answer. Okay, 186 divided by 6. It's 31. So this is going to give me x equals 31. Alright, that is how we do number 3. Number 4. This is a kite. Find the side lengths in simple radical form. Well, you have to remember the special properties of a kite. The 2 properties of a kite are, number 1, this is going to be perpendicular. The diagonals are perpendicular. Number 2, a kite has symmetry. So these angles are being bisected. You know, it has symmetry. Basically, the line PR here is the line of symmetry. So just keep that in mind just in case we need it. Well, that definitely means that if I find PQ, then that automatically will be PS as well. Anyway, it's all about the Pythagorean Theorem. All right, I think I'll do, I'm going to do this triangle over here first. I'm going to do, what am I going to do? I'm going to do this triangle over here first. Okay, the yellow triangle. Probably should have just traced it. Okay, I'm going to do the yellow triangle first. So this is going to be, if I do a squared plus b squared equals c squared, I will call this x. So that's going to be like this. 11 squared plus 6 squared is equal to x squared. Okay, 11 squared plus 6 squared. So that's 11 squared plus 6 squared. Okay, that's 157. 157. So then I just take the square root of both sides. So that's going to give me x equals. Now, if I do the square root of 157, okay, that doesn't simplify any further. So that's just the square root of 157. Okay, so far, that I just found PQ. So PQ, which is the same as PS, equals the square root of 157. Okay, so that's half of it. Now I'll do this side. Okay, so now if I do this side, all right, now I'm doing the purple triangle. A squared plus b squared equals c squared. I'll call it y this time. So that's going to be 6 squared plus 14 squared equals y squared. Okay, so 6 squared plus 14 squared, that's 232. So 232 equals y squared. Time to take the square root of both sides. All right, square root, square root. So that's going to give me y equals. Okay, so the square root of 232, hold on, the square root of 232 is 2 radical 58. So 2 radical 58. Okay, so that's the rest of my answer. So that's QR and SR. So QR, which equals SR, will equal 2 radical 58. Okay, so these are the answers to number 4. All right, looking at number 5. All right, so this is a rhombus. So once again, if this is a rhombus, that means 2 things, special properties. That means these are right angles, all of these are right triangles, and it also means this has symmetry. Okay, was this a rhombus up here? No, that was a kite. All right, a rhombus has symmetry. Both diagonals are lines of symmetry. For a kite only has one line of symmetry. So line P R was the line of symmetry. So if this was X, this was X. If this was Y, then this was Y, because PR was the line of symmetry. But keep in the back of your mind that both diagonals for a rhombus are lines of symmetry, and it's perpendicular. So, anyways, ADE is 67. I feel like I should blow this up bigger. Okay, ADE. A to D to E. Please understand that angle ADE is this angle right here. Okay, ADE. That is angle ADE, and it is 67 degrees. Okay? So there's my 67. Okay? Now, before I do anything else, the symmetry, maybe I won't, maybe I'll just see what I'm supposed to find. I'm supposed to find angle DCB. Okay, angle DCB is this angle over here. Okay, so let's go ahead and do the symmetry first. 67 degrees. Because a rhombus has symmetry both ways, both diagonals are lines of symmetry. That means if this is 67, then this will be 67 degrees. And it also has symmetry this way. Okay, so if this is 67, then this will be 67, and this will be 67. Okay, so in a rhombus, if you're given one angle, you really are given four angles. Okay, so we really need to know what, we're supposed to find angle ADE. All right, there's more than one way I can, no, I said that wrong. We're supposed to find angle DCB. Okay, so here's the angle that we're supposed to find right now. You know, I'll just keep it red. We're supposed to find angle DCB. Okay, we're supposed to find this red angle that I just drew. That's angle DCB. But look, focus on the red triangle that I'm drawing. All right, focus your eyes on the red triangle I just drew. We have two angles of the red triangle. We're being asked to find the third angle. How do we always find the third angle when we're given two angles of the triangle? Yeah, hopefully you're saying we add them up and subtract from 180, because the total degrees in a triangle is 180. So if I do 180 minus 67 minus 67, that should give me the measure of angle DCB. So let's do that. 180 minus 67 minus 67. So that's going to be 46. Okay, so obviously this drawing is not to scale, because 46 would be an acute angle and this is an obtuse angle. And if I add these up, that's going to make an obtuse angle, and this looks like an acute angle. So we're going to have to just ignore the fact that the drawing is not to scale. But anyway, the measure of angle DCB is what we were supposed to find, and it is 46 degrees. Okay, that's how we do number 5. Please ignore the fact that it should have been an obtuse angle. The drawing is not to scale. Okay, Number 6. Okay, this is a rectangle. That means the diagonals are congruent. It's not perpendicular or anything. These are not right triangles inside of here. But the diagonals are congruent. That's the special property for a rectangle, so keep that in mind. Angle XZY is 35 degrees. So XZY is 35 degrees. Okay? And ZX is 18. Okay, ZX is the whole diagonal. Okay, so we're being told that ZX is 18. So that's this. All right, that yellow is supposed to be 18. All right, but that tells me that this is 9 and 9. That's what that tells me. So let's see what things we're supposed to find. We're supposed to find angle WXZ. Okay, angle WXZ. Well, angle WXZ goes like this. All right, WXZ. All right, so angle WXZ is this angle right here. Well, that's a Z angle with the 35. So if this is 35, then this is going to be 35 degrees. So that's going to be 35 degrees. Those are Z angles. What else? We're supposed to find angle WPX. Okay, WPX. Well, let's use our symmetry that we have going. If this is 35 degrees in a rectangle, then this is going to be 35 degrees also. Okay? If this is 35 degrees, this is going to be 35 degrees. All right, so because of that, let me move this 9 for a second. We're supposed to find WPX. Put my 9 down here. So we're supposed to find this angle right here where I just put a question mark. All right, because that is WPX. Let me show it in green. WPX. So if I want to find this angle, I can just subtract from 180. We've got 35 degrees over here, 35 degrees over there. We can just subtract from 180. So I'm going to do 180 minus 35 minus 35. If I do that, 180 minus 35 minus 35, I get 110. Okay, so this angle WPX is going to be 110 degrees. Okay, now what about PY? Well, because the diagonals are congruent, each one of these pieces is going to be 9. 9, 9, 9, 9. So PY is also going to be 9. Okay, finally, angle ZPY. Okay, ZPY, that's the same as WPX. So that's also going to be 110 degrees. Number 7. This is a square. A square is a special kind of rhombus. So, just like a rhombus, a square is going to have 90-degree angles. Just like a rhombus, a square, both of these diagonals are lines of symmetry. So there's going to be symmetry in both directions. So let's see what happens. EH is 15. Okay, so this is 15. Okay, that means all of these pieces are 15, by the way. So this will be 15, and this will be 15, and this will be 15. You know, because it's a square. A square is also a rectangle, so that means the diagonals are congruent, because that's a rectangle property. So, let's see what we got to do now. Find the indicated measure. So we're supposed to find the measure of angle GHF. Okay, GHF, all right, let me move some of these 15s for a second. GHF is this down here. Okay, GHF. Well, that angle is 90 degrees. All right, because this is a rhombus. I mean, it's a square, but a square is the child of a rhombus, so it has all the traits of a rhombus. So perpendicular diagonals is one of those. So this is 90 degrees. Okay, what about angle DGH? Okay, so let me start that over again. All right, so angle DGH is like this. DGH. This is the angle that we're talking about. Well, because of the symmetry is how we're going to approach this, okay? This angle right here, the whole thing is 90 degrees. All right, this is square. Every one of these corners is 90 degrees. If the whole thing is 90 degrees, because these diagonals are lines of symmetry, then that 90 degrees is going to be split in half. So we're talking about 90 divided by 2. So in other words, this is going to be 45 and 45. Okay, 45 degrees. Each one of these angles is 45 degrees. So angle DGH, once again, okay, I'm just going to erase to emphasize this. All right, because we took 90 and we split it in half, angle DGH is 45 degrees. Okay, all right, now HF. Again, HF, which is right here, is going to be 15. Okay, because EH was 15, so all of these are going to be 15. So this is going to be 15. DE. All right, DE is the only one that takes any thought. So let's focus on DE. Okay, we are supposed to find segment DE. That is our target. Now, so to find DE, now let's do this. Look at this triangle that's purple and red. Okay, focus your eyes on this triangle. Again, this is 90 degrees, which is good because we can do the Pythagorean Theorem. We know that both of these pieces are 15. 15 and 15 because of EH being 15. Okay, so this is the hypotenuse that we're looking for, DE. So let's just do a squared plus b squared equals c squared, Pythagorean theorem. So x squared is going to equal 15 squared plus 15 squared. So that means x squared is going to equal, okay, 15 squared plus 15 squared. It's 450. X squared is equal to 450. So of course then we have to take the square root of both sides. Okay, so that's going to give me x equals. So let's do the square root of 450. That's 15 radical 2. Okay, so that is the length of DE. Okay, number 8. All right, I'll have to pick up with this later. All right, so ABCD is a kite. So we have to remember what are the special characteristics of a kite. The main thing you have to remember is that a kite has diagonals that are perpendicular. So that means that this angle is 90 degrees. So that makes this really easy. When we look at angle AEB, AEB is this angle right here. AEB. This is the angle we're trying to find. But, of course, this is 90 degrees because they're perpendicular. So think about it. If AEB is 90 degrees, and AEB is this 3x plus 21, we should be able to make that equation. So 3x plus 21 should equal 90. So we're just going to subtract 21 from both sides. Okay. So that's going to be 69. And then we're just going to divide everything by 3. So divide by 3, divide by 3. So that's going to give us x equals 23. Alright, that's all you do is 90 degrees, so you set it equal to 90. Number 9. Please understand that none of these angles are supplementary. There will be no supplementary happening. What I know is that angle C here is going to be 113 because of the symmetry. Okay? Probably should have said that this is a kite. Okay, this is a kite. So we just have to use the fact that the total degrees in any quadrilateral is going to be 360 degrees. So all of these things simply have to add up to 360. So basically we're doing this. 2x plus 113 plus x plus 5 plus 113. All that should add up to 360 degrees. So like terms, 2x and x, that's 3x. Okay, and then we've got 113, 5, and 113. Okay, so that's 231. So 3x plus 231 should equal 360. So we're going to subtract 231 from both sides. Okay, so subtracting 231, that's going to give us 3x is equal to 129. Alright? Then I just have to divide everything by 3. And that is going to give us x equals, let's see, 129 divided by 3. So x is 43. Now we're not finished because we're supposed to find all the angle measures. So look, let's be very careful. So 43, that's just the value of x. So let's do this. Well, we already know angle A is 113. Angle B, if x is 43, then we've got 43 plus 5. Okay, so that's going to be 48. So angle B is going to be 48 degrees. We already found angle C, which is also 113. Now angle D should be 2 times x, so that's 2 times 43. So that's 86. So angle D should be 86. Okay, so those are the answers. And you should probably write it down separately. So you would record your answers something like this. Of course, A is 113, B is 48, C is 113, and D is 86. All right, let's move on to number 10. Okay, this is obviously a trapezoid. And in fact, this is an isosceles trapezoid. But anyway, what matters is these leg angles will be supplementary. So these should be adding up to 180. So 3x plus x plus 8, these should add up to 180 degrees. So combining like terms, that's going to make 4x plus 8 is equal to 180. Subtracting 8 from both sides, that gives us 4x is equal to 172. And then we just divide both sides by 4. Okay, so x is equal to 43. Okay, so x is 43. That means angle E is x plus 8. So it's 43 plus 8. Okay, so that's going to be 51. So angle E is 51 degrees. Okay, angle F is going to be 3 times 43. That's 129. Okay, of course, angle G, because of the symmetry, it's going to be the same thing. And angle H is going to be the same as angle E. Okay, so that's how you would record your answers. All right, last problem. What type of quadrilateral is MKRD? Be as specific as possible. Okay, so if I were you, I would just draw some random quadrilateral at first. Now, we don't know if this is a square, rectangle, or a kite. We have no idea. So let's just mark things as we go. Okay, so first some letters. So this is M, K, R, D. You can letter it any way you want, but go in order around the shape. So, dr is congruent to mk. So for example, dr and mk are congruent. dr is parallel to mk. Okay, so dr and mk are parallel. Alright, before I even look at the next thing, I can narrow this down to a parallelogram so far. This is some type of parallelogram. Alright, a long time ago we learned several ways to show if something is a parallelogram. And one of the ways to prove that a shape is a parallelogram is, see if you can remember this. If the same pair of sides is both congruent and parallel at the same time, then that makes it a parallelogram. So we have the same pair of sides, both congruent and parallel. So this is definitely a parallelogram. Now, it's just a matter of whether or not it's a more specific parallelogram. You know, is it a rectangle? Is it a square? Is it a rhombus? So let's see if the remaining detail narrows it down further. So the remaining detail is that MR is congruent to DK. So we're talking about diagonals here. So MR is congruent to DK. Okay, so basically this red line is congruent to the blue line. Now we already know it's a parallelogram, so it can't be a trapezoid or a kite or anything. So there's only one parallelogram that has diagonals that are congruent. What is the only parallelogram that has diagonals that are congruent? Hopefully you said rectangle. So we knew it was a parallelogram, but more specifically, it is a rectangle because only a rectangle has congruent diagonals. Okay? So we know it's a rectangle. We can't go any further. It's possible that it's a square. Could be a square. We don't have enough information to prove that's definitely a square. But it's definitely some sort of a rectangle. So that's it for the homework.